Alright, now that we're recording, go ahead and switch scenes for you. Alright, if you just got in here, don't forget to add your comments to the chat or any questions that you have, and I'll answer them as I work through them. Wrote down a little bit of a agenda of things I want to cover, things that are updated, and then I'll go from there, and I'll answer questions in between. So the first question I got, which is in my agenda actually, was two parts. The first thing is for people that want to build their own rig with custom components, or if they want to develop anything on the actual system. I have added developer ports as well as 30 by 30 and 20 by 20 mounting options onto the power distribution board itself. So let me go ahead and drill down into that so you can see it. Alright, so here's the main stack layout, and then I can drill down to that even further. So let me go ahead and do that. Alright, so this is the first board that will be assembled and everything. And you've got your developer and flight controller outputs here. They'll have pinouts and everything in the documentation for them. And then you have a pinout for your LED controller if you wanted to use a different one. You've got a VTX pinout, and you've got a S-bus receiver pinout. I'm still working with Spectrum and getting that all aligned in, but right now it's compatible with any S-bus receiver. And you have on this, you have the stack pins for the underarm LEDs, you have the stack pins for the ESCs, and then you have the stack pins up front for the LED controller and the two in the back for the flight controller. In the front here you have a camera pinout plug, so you can plug in your camera to that, no soldering, as well as the tilting mechanism plug. So everything is plug in, you don't have to solder anything except for the two battery leads in the back. And I'm still working on labeling everything on the actual board, so if you have any preferences on what you'd like to see make it onto the actual print of the board, then just let me know. This model here, I'm still working on getting a 3D model for that, but that's the shunt resistor, and that'll measure all the current running through the board. So anything that hooks up to the power distribution board will be measured through that, so hopefully we get a more accurate current reading. The next thing that goes on to that is you have your let's get all these spacers in here. So you have your how the stack is assembled is you have your first row spacers, or your main body spacer as it will probably be called, and this just has cutouts to save weight, as well as cutouts to allow pins to go through. Like here, the underarm LED pins will go through there. The servo that controls the tilt will go here, and then these holes are big enough that you can just slide your 20 by 20 or 30 by 30 stack screws through it, and everything will line up perfectly. Then you have these little 2mm spacers that sit on the top of that. I can add this into one file if needed, but you have the option to use off-the-shelf 2mm spacers with it if you wanted to do rubber grommets or something like that. Then you have the PDB that sits on top of all of that, and then you have the third row of spacing, which are 5.2 millimeters tall. They sell these spacers on Amazon, but you can also print them or CNC them if you'd like. There will be files for that provided. On top of that, the next thing that I would assemble in is the actual camera tilt mechanism. Let's see if I can reset origin center. Yeah, that does it. Okay. And then this is two parts. It's a linear servo that screws in with 4 screws. You don't have to use all 4. You can use 2 if you want. And then it has this arm, and that will connect up to the camera to allow it to tilt. Next thing on top of that, you have the LED controller and the flight controller. The LED controller will sit on top of this servo and arm, and I've tested the throw distance, and it doesn't actually move into here. So you're all good with that. And then it just stacks nicely into the pin, so you don't have to worry about it. I've moved the USB-C connector to the inside, so you can do it without taking all the front components out. I'm still working on if this is the best position, and I'll explain why I think that in a minute. On top of everything goes the receiver and VTX assembly, and this is why I have to think about moving this, because you can't get to that USB port when this is attached. And currently it's modeled to fit the RXSR and the let's see, is it get this right, the TVS Unify Pro V3, and I chose those components because they have removable antennas, so they can just snap into the replacement cables that will be made up that screw into the back sled assembly. And then after all of that's done, you have your hardware that secures everything, and it also screws into the bottom plate, and they go through the main body plate, and they go through the back sled and the front camera mount, and secure those two parts in place. So the camera assembly goes here, and it screws into these brass insets, and the main frame body will go in between that space. And the same thing is true with the antenna assembly, which goes in the back here, and there are also inserts in here as well. And then you have the SMA connectors with, these are just modeled as pagodas. I'm thinking of adding in stubby models just to cut weight down and drag. Hey RDAL337, how are you doing? So the next thing I want to show before it actually goes together is the LED components, and this is the underarm LEDs as well as the top LED panels, and they sit in and go right to the underarms go right to the main body plate, and the upper arm LEDs go to the ESC boards. I'll hide those for a minute. The main frame I'll add in here, and those have the printed ESC spacers in. And I can add in the LEDs and the ESCs, which slide in and everything connects up. Then I've also added in motor models, which have hardware as well, so they screw in, and you don't have to use all 4 screws. If you don't want, you can. That's not needed. And now that I have all this in, you can see there's a custom made plate that'll sit on the back of the this is a Runchem Micro Swift, and it just screws in here. I have propellers made, and these are Lumineer 6.7 by 3 by 3, and they're the folding propeller model. I couldn't find a 7-inch propeller model, but the clearance at 6.7 is enough for the 7-inch propeller if you want to go with the full-size propeller. And after that we have the canopy, which is the both sides and the back fin. The back fin isn't the black, because I'm still working out where the set screws go in. And can't hear you. Hang on a second. No, I can hear it. Check the. I'm viewing the stream on my side. Is my mic quiet? Is that what it is? Because I can turn that up. Yeah, I have the stream up on Twitch, and I can hear everything fine. Okay, let me. I'll turn my mic up a little bit for you, if that works. Yeah, hopefully that fixes some things. Last thing, I have in here the electronics which is just a temporary file, and that has the spine LEDs in here that I'm still working on getting models for, as well as their advanced radio package, which doesn't fit on the new frame. I have to change that. But the advanced radio package, that'll be replaced by the AI package, and this board here will have two functions. It'll have a in the future it'll have custom VTX and receivers in them, and there'll be a FR Sky and a Spectrum version, so you can get all custom components if you want. As well as on the top there'll be a system that allows the AI to listen to the camera signals, any sensors that'll go on, and the receiver commands, and then it'll learn from those of how to control the drone. And then when you switch it to autonomy mode, it'll turn off the built-in receiver and use the AI receiver spoof, and that'll then control the drone. That's how that is planned on working. And the battery in here is just a temporary mesh model, and I'm not exactly sure why it's not showing up, but that's the size of it. It takes up a lot of the space in there, but oh, that's why. Okay, there we go. So that's the size of the full battery, and yeah. If I turn on the canopy, everything fits nicely in there, and everything works. Let me respond to this. And yes, my keyboard is loud. I'm sorry. Alright, so I'll move along. Use of standard flight hardware. That's what I've done with the 30x30 and 20x20 stack mounts, as well as the developer output pins, so you can add in your own VTX receiver, and as well as the RX and VTX assembly. This file will be provided so you can customize it to your own receivers or VTXs. Completed 3D model and electrical. Yeah, so if you notice from the last stream or the videos or updates that you've seen, the power distribution board has been green. How I develop things is green means that it's not finished designing. It doesn't mean that it's been prototyped yet, but it just means that it's not designed yet. But when the board is black in models, that means that it's designed and it's ready to go through a first prototyping run. For information, that's just more of I'm developing pinouts and documentation for how to do your own custom development with the kit. The practice race kit, that's I'm working on getting a model for that, but it's going to be pretty much, if I can just pull it up with this is sort of how it'll look with the canopy enabled, but I'm going to keep that off just so you can see some things. So it's just going to be the bottom plate, the LEDs, and it's not going to have the LED spacers, or the ESC spacers, sorry. And then there's going to be a 3D printed board that goes in and allows you to mount any kind of stack. It'll go up and down, and there will probably be 2 or 3 sets of placements for everything, so you can place them anywhere on the board that you want, or on the system that you want. What's next for the project? The next thing for the project is going to be actual prototyping. So how I'm going to prototype things is I'm going to verify that all of the components that are similar between the boards, so like any resistors that are the same value, are all coming from the same manufacturer, so I don't have to order a bunch of different packs from many different manufacturers. I can just order them all from one manufacturer. And then I'll do a bulk BOM list of everything that's needed for the kit. I'll order that, and then I'll do a bulk order of all the circuit boards. And once I have all the circuit boards, I can start assembling things, and I'm going to assemble them but then not hook them up individually. So I'm going to hook up the like for example, I'll hook up the LED boards, and then I'll hook them up to a 5-volt power supply, and I'll hook it up to another LED controller, probably just a beta flight controller that I can just test off that and see if they work and see how everything goes. Once those are good, then I'll move on to the next component. If they fail, then I'll still just move on to the next component. I'll just make a note that I have to go back and tweak something. And once all of the components are done, then I'll start assembling things. So I'll first assemble the main stack. So everything that goes on the stack will be assembled, and then the ESCs will be assembled, and then the LEDs will be added to it. So just step by steps. After that, I'll do starting my tests and everything like that. So I've already run through pretty much all of my my major talking points. Now I'll open it up to questions to see how everything's going. Okay. Just a little bottom view for you. If you go into this, the front two 20 by 20s are kind of hidden, so you might have to add the screws before you stack everything together, but that's not that hard to do, and there's enough clearance for button head screws, and I think these socket head screws will even work for you. And if you're wondering why I used two different sets of headers instead of one big header, that's just because I didn't find a model big enough to fit all of the connections on it. I didn't find an 8-row header that everything is stacked to, but that might change. Also, this is a kind of complex board, so refitting it for an 8-pin header might be complicated. I'm going to go ahead and launch Eagle just so you can see a little bit of the developer pinouts and everything, see what goes into that. Okay, so on the developer side, you're going to have a VBAT, which is your which comes from the actual current sensing system. You'll have a VCC for full power. You'll have ground, you'll have the 5-volt, a current pin, and then motors 1 through 4 in here. Next thing on the pin header list is you have your RSSI, your S-Bus, your VTX audio, video out and video in, as well as your LED RX, LED TX, camera tilt, and camera control, and that's on one header. On the other side for your LED control, again, that's just TX and RX, and those go to these pins. For the VTX, you have video out, video in, VCC, ground, and audio. Now, if you're wondering, for the video in pin, that's directly connected to the camera header. So if you don't want an on-screen display or want to use a built-in on-screen display on VTXs, you can use that. So that's what that video in pin is for. Otherwise, you just have your audio, your ground, your main power, and your video out. And then on your S-Bus pins, pin header, you have ground, 5-volt, RSSI, and S-Bus. And there will be another header in here for Spectrum, or it'll expand up to, this will actually it'll go to like a 5-row header instead of a 4-row to support the Spectrum pin, the SAT pin. And working your way up the board, cam is video in, 5-volt, ground, your camera control, and your ground. And that has the built-in circuit for camera control, so you don't have to add the resistor or the capacitor or anything like that. And then your tilt has just 5-volt, ground 5-volt, and your camera tilt. And that's just mapped to a servo pin. Down here, I have these other models that I'm working with. These models that I've put in, I made up myself. This one and where is it? This one. And they're accurate, but they're for through-hole connectors, so the connector can connect to a circuit board, but then connect 2 other circuit boards to it, one on the bottom, one on the top, so it has holes all the way through the connector. And these are just the standard, like they don't have holes on the bottom, you just plug something into it from the top, and that's it. So I'm experimenting with if I want to add those in, but they're just off to the side right now. Let me just make sure I'm not getting any comments from any of the other places that I've posted anything, and then we'll probably wind it down since there's no questions popping into the chat. So there's nothing there. And let's check YouTube. Nope, there's no comments that I haven't already replied to any of those. Alright, well, as always, the streams are recorded and added to YouTube after they post. The reason I don't add them to Twitch is because Twitch only keeps the videos for 14 days unless I'm a partner, and then they keep them for 60 days. But for the record of the project, I have them both saved on hard drive as well as saved on YouTube for backup. And so if you're not already, go ahead and give the stream a follow. If you're watching this on YouTube, consider subscribing. And if you want to get notified of when I go live, just follow the stream. Or ring the bell on YouTube and you'll get a notification when I upload the videos. So thank you guys for watching, and I'll see you next time.